Hello everyone, my name is Shruti Parab and the topic for my literature survey is Wi-Fi fingerprinting based indoor localization techniques.
The location of a user or a device can be of extreme importance. In case of outdoor technologies, the GPS signal is widely used to determine the position of a user. However, in case of indoor environments, this GPS technology fails to deliver. The GPS signal is weak to travel indoors, and the location found out is not precise. Hence, there was a need to develop an alternative technique for indoor localization. Over the years, various technologies like Bluetooth, FM, radio, Wi-Fi, etc. were researched to find the best possible technology suited for indoor localization. These technologies were compared using the performance parameters like cost, coverage, accuracy, and power consumption. Among all these technologies, we observe that today Wi-Fi is the most accessible technology indoors. In an indoor environment, almost every mobile user is connected to Wi Fi. This can be used to our advantage for indoor localization. Using Wi Fi for indoor localization techniques can be beneficial as it will save cost. Since the Wi Fi network is already widely used in indoor environments, there is no need to install an external hardware or any software operations. Indoor localization using Wi-Fi can be performed by using the receive signal strength. The receive signal strength values over all the points in an indoor environment can be calculated in an efficient manner to deliver the location of the user.
In indoor localization using Wi-Fi, the indoor space is divided into various points. These points are segregated into the access points, the reference points, and the user itself. The reference points are like landmarks in the indoor space. The received signal strength values is found out at the access points. The received signal strength value at any point in the location is called a location fingerprint. The basic principle of Wi-Fi fingerprinting is that each fingerprint should have a unique value. The indoor localization using Wi-Fi consists of two phases, the online phase and the offline phase. We will discuss each of the phases as follows. Offline phase. An area of interest is considered in an indoor environment. This area of interest selects certain reference points. The indoor environment has access points distributed all over the space. The received signal strength value is recorded at these access points. This received signal strength values are nothing but the fingerprints. Later, these fingerprints are sent over to the reference points. The reference points calculate the RSS fingerprints. These RSS fingerprints are sent to the localization server. The localization server stores these values in the fingerprint database. Online phase. In an online phase, the user moves around the indoor environment. When the user is closer to an access point, it records the received signal strength value at the access point. This received signal strength value is the fingerprint of that particular user. This fingerprint is calculated at the reference point. Further, this reference point sends the fingerprint to the localization server. At the localization server, the fingerprint matching of from the online phase and the offline phase takes place. After this matching algorithm is completed, if the fingerprints of the online phase and the offline phase are matched exactly, then the target location is estimated. Wi-Fi fingerprinting. The received signal strength values at n different access points are recorded at j different reference points. These received signal strength values are nothing but the received signal strength fingerprints. These fingerprints are stored in the database. With research over the years, it has been observed that the access points have P different power levels. Hence, the fingerprints also vary according to the power levels. Thus, the RSS values are a function of the position of the reference points, the position of the access points, and the power levels as well. At the localization server, the matching algorithm performs the matching of fingerprints from the online and the offline phase. The different algorithms that are used for matching are as follows. We will discuss them further.
K nearest neighbor. This is the most commonly used algorithm. Here we calculate the difference between two fingerprints, the unknown fingerprint and the predefined fingerprint known to us. This difference is calculated by using the Euclidean distance formula. Here, the new coordinates are generated for the unknown fingerprint. These coordinates are generated using the coordinates of the predefined access point. Many such values of these coordinates are obtained, and later these values are sorted out to find the kth neighbor which is closest to the reference point. This is the basic operation of the kth nearest neighbor algorithm. Since KNN is one of the most popular algorithms, there have been researches made to modify this algorithm. Professor Rodrigues, along with other professors, suggested a weighted KNN method. This method varies according to the weights in addition to the coordinates, whereas Professor Kodayari, along with other professors, proposed a predictive KNN based method. This method is a bit different. It predicts the next displacement of the user depending on the previous location of the user in addition with the speed. It is observed that this PKNN method performs 33 times better than WKNN. Neural network based algorithm. The neural network based algorithm has artificial neurons which imitate the brain and the neurons in the brain. The artificial neurons in neural networks are called perceptrons. These perceptrons are interconnected to each other like the neurons in the brain. These form the multi-layer perceptrons. It is observed that the relationship between the output variable and the input variable in the neural networks is of non-linear nature. Bayesian estimation model. This model works according to the Bayesian theorem, which
Here
gives
we
us the
will discuss the
probability
other
of the unknown
algorithms
entity.
used
Here,
for
we
matching.
have the
The
actual
linear
location
regression
in the
model
online
is a
phase.
representation of
Now,
a linear
in the
relationship
offline
between
phase,
the output
we
and the
find the
input variable.
probability of the
This
received
is
signal
much like
at the
the
unknown
weighted
location.
KNN method which
Further,
was
the
proposed,
matching
which
of
used
this
weights in
probability
addition to the
with the actual
coordinates.
location
There
takes
also,
place.
the output
If the
and the
matching comes out to
input
be perfect,
variables
the
had a linear
estimation is
relationship
correct
between them.
and it will give us the exact location.
It may happen sometimes that the received signal strength values from n access points may be the same. To avoid this, the support vector machine algorithm is used. The support vector machine algorithm is the algorithm which visualizes the received signal strength and then segregates it by using a hyperplane. The vectors which are closest to the hyperplane are called the support vectors. With the increase in research in the field of indoor localization, there were some problems that were encountered by the researchers. To overcome these problems, the researchers have proposed solutions. We will discuss some of them as follows. The nature of receive signal strength based architecture is quite random. To eliminate this, fusing of the receive signal strength values is proposed. Thus, elimination of the random probability also takes place. Along with the receive signal strength values, to estimate the location of the user, We can also utilize the orientation of the user. This orientation can be detailed in any of the four directions. This will help us to determine the precise location of the user. Sometimes the fingerprint duplication at a single point might take place. This will negate the basic principle of fingerprinting. Thus, the uniqueness of the fingerprint won't be able to maintain. To eliminate this, the receive signal strength spread technique is utilized. So far, we have considered the fingerprinting technique over a closed room environment. However, if we consider an entire floor, which will have many such rooms, we will have to account for the user motion between the rooms. This is proposed in the location in fingerprint space. In conclusion, the Wi Fi based fingerprinting is widely adopted using different methods and modifications but for the same purpose. The flexible adaptation of various modifications makes Wi Fi based fingerprinting an ideal method for indoor localization.